we have seen this complete flow, how it is working, given an input image of Regression, how it will be going through convolution, review, and pooling layers, and finally, how it will be giving the predicted output. This flow we have seen completely in the last video. And at the ending of the last video, I have asked you two questions. First one is, what kind of problems can we solve with the help of CNN? That is, can we solve regression problems, or can we solve binary classification problems, or can we solve multi-class classification problems? This is one question. And the second question is, what are hyperparameters and parameters in case of CNN? Okay. So give a thought about these two questions and then only jump into this particular video. Comment down your answer for these two questions, what you feel about it. Okay. Now let me answer these two questions. Basically, let's answer the same for ANN. If you guys remembered or if you have seen my videos of ANN, I have clearly told you that we can solve all these three kinds of problems. That is, we can solve regression problems, and also we can solve binary classification problems, and also we can solve multi-class classification problems, right? In case of ANN, we are having this as the exact architecture, right? So this is the exact architecture that we used in ANN. If with this architecture, if we can solve all these three problems, then obviously with CNN also we can solve all these three problems, right? That's why the answer for this, in case of CNN also, it can solve all the three problems. And how we are able to solve all the three problems in case of ANN, what are the main changes that we are making? If you guys remember, the main changes that we are making is in the output layer. In CNN also, it's the same. Here in the output layer, we'll be making the main changes. So in output layer, we'll be making two main changes. One is in the activation function. So the activation function that we'll be using in case of a regression problem is linear activation function. The second change that we'll be making, it is in the number of neurons. So the number of neurons will be based on the number of outputs. It can be possible that there can be multiple outputs in regression problem as well. One such example of multiple outputs in regression problem is finding location. Location is the output in our case. How can we find some exact location? That we can do with the help of latitude and longitude. So these two are continuous values. That's why this kind of problems comes under regression problem. And in that case, the number of neurons in the output layer should be 2. And the activation function that we'll be using is linear activation function. Okay. So I hope in case of regression, how we can solve is very clear. In case of CNN also, we can solve some regression problems. Basically, in CNN, what we can do is, let's say this is the image that we are given. In this image, let's say we are having face. So this is the whole image. Face is present in this portion only, right? In this square box only. So in order to find the exact location of face, we can give these 4 points. Okay. So in order to give these 4 points, or simply we can give this point and this point, which will give us the square box. Okay. So for predicting these points, then we need to give x1, y1 and x2, y2, right? So these points we need to be giving as the output. All these are continuous values, that is x1, y1 and x2, y2. That's why that will come under one regression problem. Such kind of regression problems can be solved with the help of CNN. Like binary classification also we can do. The simple example is like, given an image of cat or dog, we need to predict whether it is a cat or dog. Okay, that is one simple binary classification example that also can be solved with the CNN. In that case, what will be my number of neurons? Simply, in case of binary classification, the number of neurons can be either 1 or it can be even 2. The concept is same in case of ANN or CNN. So if you guys remember, in ANN also we made these changes in activation function and the number of neurons for regression, binary classification and multi-class classification. So let me write it over here once again. Let's say if it is regression problem, then what is the activation function that we'll be using? The activation function that we'll be using is linear activation function. What is linear activation function? Whatever input that we get, we'll be using the same thing as the output. Okay, so that is what linear activation function is. And what is the number of neurons that we'll be having in the output layer? The number of neurons in the output layer will be equal to the number of outputs that we wanted. If we are finding location, then we wanted to predict two outputs. Or if we are finding, if we are trying to solve this kind of problem, then we want four outputs like x1, y1, x2, and y2. We wanted to find these 2 points so that we can make a box around the face. In that case, the outputs will be four. Like that, based on the application that we are trying to solve, this number of outputs will be dependent. And after regression, the next problem is binary classification. In binary classification, the number of neurons in the output layer can be either 1 or 2. If it is 1, what is the activation function that we'll be using? If you guys remember, the activation function that we'll be using is sigmoid. This we have used in logistic regression as well. Please try to remember all the things that we have discussed in the previous videos, then it will be more clear. And what will be my activation function if we are using two number of neurons, then it will be softmax. And if it is multi-class classification, then also the number of neurons in the output layer will be dependent on the number of classes. So if you are trying to solve some MNIST problem, what is MNIST problem? If you don't know, MNIST is a problem where we wanted to classify numbers. We'll be having handwritten digits of 0, 1, 2, 3, so on till 9. And based on the given image, we need to predict whether it is 0, 1, 2, 3, like what digit is it. Okay. In that case, we'll be having 10 classes. Or in some other case, we can have even more classes as well. Okay. And the activation function that we'll be using is softmax. And what softmax will be doing? Softmax will be giving us the probability score for each of the classes. Okay. This is what we have discussed in ANN as well. The same thing applies over here as well. And if you guys remember, there are three main steps in any of the machine learning algorithms. One is the hypothesis, and the second one is the loss function, and third one is the optimizer, right? Whatever that we have covered in CNN, that will come under the part of hypothesis. So this whole CNN structure that you're seeing over here will be our hypothesis, okay? And then we'll be having the second one, that is loss function. What kind of loss functions can we use? We can use the loss function based on the problem that we are trying to solve. For all the problems, we can't use the same loss function. Okay. If we are trying to solve some regression problems, then the loss function that we can use is something like mean squared error. Okay. And if you are trying to solve some binary classification problem, then you can use binary cross entropy. And if you are trying to solve some multi-class classification problem, we can use categorical cross entropy. All these things we have already discussed in ANN. That's why I'm quickly going through all of this. Okay. If you want it in more detail, please refer to the ANN videos. And then finally, we'll be having the optimizer. And in case of optimizer, the simple optimizer that we can use is GD. But we discussed what are the problems with this particular GD. So we can go for some modifications of GD like SGD or MBGD. But in these also, this problem of GD prevails. So we can go for some advanced optimizers like ADAM, ADAGRAD, RMS prop, all of this. Okay. We haven't gone to details of these. Maybe in future we might go into the details of these particular optimizers as well. Okay. For now, just remember these can be used. Okay. That's it about what kind of problems that we can solve with the help of CNN. In the next video, we can see what parameters and hyperparameters in case of CNN. Okay. We'll try to answer this particular question. That's it for this video. If you have any doubts, please comment down in the comment section. I'll try to help you out. Thank you everyone. Bye bye.